You are falling toward an object so massive that light itself cannot escape. There is no surface to hit, no bottom, no crash, just a point in space where the rules of reality break apart and everything you know about time, distance, and your own body stops making sense. And you would not even realize the moment it became too late. To understand what falling into a black hole would really feel like, you first have to understand what a black hole actually is. In 1916, a German physicist named Karl Schwarzschild solved Albert Einstein's field equations, the math that describes how gravity warps space and time. While sitting in a trench on the eastern front of World War I, he found something disturbing. If you compress enough mass into a small enough region of space, gravity becomes so extreme that nothing can escape. Not light, not radio waves, not a single particle of anything. The boundary where escape becomes impossible is called the event horizon, and once you cross it, you are not coming back. But here is the thing that makes black holes so terrifying. You would not feel yourself cross it. Imagine you are floating in space, and somewhere ahead of you is a stellar mass black hole, one formed from the collapse of a massive star, roughly 10 times the mass of your sun. It is invisible, completely black against the star field behind it. The only clue something is there is a faint ring of light around its edges, photons, tiny particles of light that are spiraling inward and glowing as they heat up. This ring is called the accretion disk. It is made of gas, dust, and debris that got too close and is now being shredded and superheated to millions of degrees. You are falling toward this thing at an accelerating speed, and the first thing you would notice is not pain. It is silence, absolute silence. There is no air in space, no sound, just the faint hum of your own breathing inside your helmet and the slow beat of your heart. As you get closer, something strange begins to happen to the light around you. Stars that were behind you start to shift. Black hole is so massive that it bends the path of light traveling past it, a phenomenon called gravitational lensing. Einstein predicted this in his general theory of relativity. The Event Horizon Telescope captured the first direct image of it in 2019 when it photographed the supermassive black hole at the center of the galaxy Messier 87, a monster 6.5 billion times the mass of your sun. What they saw was a dark circle surrounded by a glowing ring of bent light. From your perspective, falling in, the universe would start to look distorted. Stars behind you would appear to stretch and smear into arcs of light. The sky would warp. It would feel like falling into a lens that reshapes everything you see. And then you would reach the tidal zone. A black hole does not pull on your whole body equally. Gravity gets stronger the closer you are to the source. So the parts of your body that are closer to the black hole, let us say your feet if you are falling feet first, feel a stronger pull than your head. This difference in gravitational force across your body is called a tidal force. And for a stellar mass black hole, these tidal forces become lethal long before you reach the event horizon. Your feet would begin to accelerate faster than your head. You would feel yourself being stretched. Physicists have a name for this. They call it spaghettification. And yes, that is the real scientific term. Roger Penrose, the British mathematical physicist who won the Nobel Prize in 2020 for his work on black hole singularities, described what happens mathematically. As you approach the singularity, the point at the center where density becomes infinite and physics as we know it breaks down, the stretching forces increase without limit. Your body would elongate. Your bones would snap. Your cells would tear apart. The process would reduce you to a thin stream of matter spiraling inward, like a strand of pasta being pulled through a cosmic press. For a stellar mass black hole, this would happen while you are still outside the event horizon. You would be dead before you crossed the line of no return. But here is where it gets truly strange. If the black hole were bigger, much bigger, the story changes entirely. A supermassive black hole, like the one at the center of your own Milky Way galaxy called Sagittarius A star, is about 4 million times the mass of your sun. Its event horizon is enormous, and because it is so large, the tidal forces at the boundary are surprisingly gentle. You could cross the event horizon of a supermassive black hole and feel almost nothing. No stretching, no pain, no sudden sensation that something has changed. You would just pass through, and this is the part that breaks your brain. Once you are inside the event horizon, every direction points toward the singularity. It is not like being trapped in a room where the walls are closing in. It is like time itself has tilted. Moving forward in time and moving toward the center become the same thing. You cannot turn around. You cannot slow down. You cannot send a message out. Every photon you emit, every signal you send, every radio wave you broadcast, all of it curves inward toward the singularity just like you do. Kip Thorne, the Caltech physicist who won the Nobel Prize in 2017 for the detection of gravitational waves, spent decades modeling what you would see inside a black hole. In his research and later in advising the film Interstellar, he calculated that the view from inside would be unlike anything in human experience. The universe above you, the stars, the galaxies, the light of everything you ever knew would compress into a shrinking circle overhead. Like looking up through a tunnel that gets narrower every second, and below you there would be only darkness, not the darkness of a room with the lights off, the darkness of a place where light has no meaning. Time would do something you cannot intuitively grasp. Because of extreme gravitational time dilation, a real effect predicted by Einstein and confirmed by experiments with atomic clocks on GPS satellites, time for you would pass normally inside your own experience. You would feel your heartbeat. You would feel your breath. But to anyone watching from outside, you would appear to slow down, freeze, and then fade as the light from your body redshifts into invisibility. You would become a permanent ghost image smeared on the surface of the event horizon, growing dimmer over billions of years. From your perspective, you would watch the future of the universe unfold above you. Stars would be born, galaxies would collide. The universe would age, all of it compressed into the minutes or hours of your remaining existence. You would see more of time than any human has ever seen, and none of it would help you. The stretching would return. Even in a supermassive black hole, as you fall deeper, the tidal forces eventually become infinite. Your body would be torn apart at the molecular level, then the atomic level, then the subatomic level, and at the singularity our equations stop working. General relativity says density becomes infinite. Quantum mechanics says that is impossible. This is one of the biggest unsolved problems in physics, the place where our two best theories of the universe contradict each other. Stephen Hawking proposed that black holes are not entirely black. Through a process now called Hawking radiation, they slowly leak energy and over unimaginable timescales, trillions upon trillions of years, they evaporate. The black hole that killed you would itself eventually die. But you would be long gone, reduced to information that physics is still trying to understand. Here is the twist that changes everything about how you think about this. You are not in danger of falling into a black hole. The nearest known black hole candidate is over 1,000 light-years away. You would need to travel at the speed of light for over 1,000 years just to reach it. You are safe. But you are already living inside the effects of a black hole right now. The supermassive black hole at the center of the Milky Way, Sagittarius A star, is quietly shaping the galaxy you live in. Its gravity influences the orbits of billions of stars, including your sun. The Event Horizon Telescope team photographed its shadow in 2022, and what they found confirmed that Einstein's math holds even in the most extreme environment in the universe. The black hole did not ask for your attention. It does not need you to understand it. It has been doing what it does for billions of years, bending light, crushing matter, warping time, long before your species existed, and it will continue long after your species is gone. You sit in your room, on a planet orbiting an ordinary star, in the outer edge of a galaxy held together partly by an invisible object so dense that it breaks physics. You scroll through your phone. You worry about tomorrow. You forget that you are riding a rock through space around a nuclear furnace, inside a galaxy anchored by a thing that eats light. The universe did not make you insignificant. It made you temporary. And somewhere at the center of everything you belong to, there is a darkness so complete that even time stops making sense. You looked up at the stars tonight and wondered what is out there. But the truth is, the most terrifying thing in the universe is not out there. It is at the center of your own galaxy, silent, invisible, patient, and it has been waiting since before your sun was born.